Okay. Yeah. Okay, yeah. So I am talking today about mapping and modeling moral panic in the mainstream media. So I'll just get into some definitions here. So the idea of moral panic comes from Cohen and the book Folk Devils and Moral Panics. And it's defined as when a condition, episode, person, or group of persons emerges to become defined as a threat to societal values and interests. And the claims, while they're sometimes completely false, sometimes they simply exaggerate the seriousness, extent, typicality, and or inevitability of harm. So one of the earliest examples of this, which was obviously like fully fabricated, are like the 1500s witch hunts. But there are modern examples too, or like more modern examples. So stories like this could be the kids are eating Tide Pods. Parents are practicing Satan.
It's syrup.
It's syrup. Yeah. Yum. Parents are practicing Satanism with their children. Like parents actually went to jail over this, and it was made up. There's a social contagion of quote unquote transgenderism among kids. To that, I remind the room of this trend. Wow, it really seems like when we give people the resources to be who they are, things kind of plateau at a stable rate. Social contagion of left-handedness. I know like social contagion is like important to the field of complexity science in a number of ways, and it's kind of been co-opted by bad actors in this way. But anyway, moving on. And also this is for Brendan and anyone else who was at Peter Dodds' NetSci talk. In the basement of a pizzeria, Hillary Clinton murders babies.
That was true.
Yeah. And then the one that really inspired me to start working on this is the general panic that critical race theory, which of course is like this very specific legal theory that's studied really only at the graduate level, postgraduate level, is being taught to elementary school children and being forced upon federal workers. I'm in this image, by the way. I am federal workers because I was at Sandia at the time that Chris Rufo was going on Fox News. Okay, so what's next? I can't remember. Oh yeah, so this fits into a larger framework of what I called last week the misinformation to legislation pipeline, where things like start in insular spaces. They can be think tanks, they can be forums or whatever, and then they become mainstream, and eventually we hit legislation, which we did with the critical race theory stuff and the LGBT stuff. So this is kind of more from like step 1 into step 3, like fringe into mainstream. That's the section of this cycle that I'm talking about here. Okay, so I'm gonna need some data for this. This is the craziest acronym, GDELT TV GKG. This is the Global Database on Events, Language, and Tone, American Television Global Knowledge Graph. Thank you.
Also an airport.
Oh, it's yeah, the call signs. Yeah, and so I'm going to show a little bit of how this works because this is a super powerful resource. So here I have a query. So I'm doing, I'm searching for invasion, and then in the context of migrant, migrants, immigrant, or immigrants. So this looks for the word invasion in proximity to any of these terms. And then we get a time series plot and a handful of styles of the different news stations talking about this. There's like a major spike right here, and that's because this kind of language actually appeared in the manifesto of a mass shooter in El Paso, Texas. And then we also get the individual instances of this happening. And you can download the CSV. You can only get, I think, 5,000 entries at once. So what I did is for all the terms and search queries that I was interested in, I just pulled these every single day over a long time. And they let me do it. I only got kicked out of the website once. Okay, back to this. Okay, I'm going to assume that this hide floating median controls. Okay, cool. Okay, so some exploratory plotting on this data. So this is just focusing on the critical race theory query. We can make a network of news stations, and so this is making a naive assumption that if one station talks about this the day after a previous station did, that constitutes a response. So that this is definitely like capturing more. It's capturing something different, but it's like sort of proxy. This is just a very exploratory thing. And these edges are, again, colored temporally, so we can see that like there's really everyone's talking about this. And then CNBC and Bloomberg talk about it less, so they end up kind of forced out in the Spring Force layout of this network. And also just basic volume over time. I ended up focusing really entirely on the big four. Really, it's big three. It's MSNBC, Fox, and CNN, and then FBC is Fox Business, so it's kind of just also Fox. So yeah, moving on from there. So this is interesting, but it's really just news stations, and there were not very many of them. So what if we do this according to shows? We have the show that this appeared on, each entry, so we can just do shows instead of news stations. Ugh! Okay, there's clearly a lot going on here. Maybe we can split it apart. So this is like aggregate over like 2020 through 2024. So what if we just do 1 month? Well, now we can kind of see something, and let's go to the next month. Okay, still a bit much. So we'll return to this at a later date, not today. But there's something interesting here. This is also like a very special kind of visualization where you can just see volume by overlapping text. Okay, so some tools that I'm going to use now. So I'm going to ditch the networks theory for the next while and just focus on models of adoption. So I had a really helpful conversation with Scott about these models of adoption. And so the first one is the first one I'm going to talk about is the broadcast model. These are all iterative things. So we have like the number of infected at one time is equal to the number at the previous time plus the probability, the broadcast probability times the susceptible population. So this is like a really simple growth thing. And this type of model results in what's called an R curve, where it just kind of like starts by going up and then is concave down the whole time. So this is your interpretive dance. Goes like that. But then there's also the diffusion model, where this comes from the idea that people adopt something based on those in proximity to them, and then the aggregate is now, it's probability of diffusion times susceptible population multiplied by the fraction of the population that's already infected. And so we get that. This gives us an S curve, so flat, up, flat. And then we can also combine these things. So let's say we take these two things, we take this blob and this blob, and just put it together. So this is kind of like the Brangelina of models. And so this is called the broad fusion model. It's actually called the Bass model, but so for Frank Bass. And this is the one that I'm using now. So we can fit this to the curves that we see, and the values of PB and PD can kind of tell us a little bit of what's going on. Is this diffusion? Is this is this more diffusion? Is this more broadcast? Is it more or less a combination of the two? So, fit check. So we have the data here. So this is just the number of unique shows. There are flaws to this approach, which I'll talk about later, but the number of unique shows over time that have mentioned critical race theory, starting in June of 2020. And so it kind of has these jumps, and we fit the BAS model to it, and then taking the ratio of PD over PB. So if this is greater than 1, then it's more diffusion than broadcast. If this is less than 1, then it's more broadcast than diffusion. And so we have like some more. So we have that this is kind of more on the diffusion side, but we don't really know when to stop this thing. So like, you can imagine trying to fit the curve with only this much data or only this much data. And so we can do that and then see like what this ratio is over time. So introducing a little inset plot here. It took me way too long to figure out how to visualize a fraction that can go from 0 to infinity. But I landed on arctangent. So this is, yeah.
That's on the advanced bingo card.
Yeah, so if this value is 1, then it's all diffusion. If this value is 0, then it's all broadcast, and if it's 1, then it's both. So, or sorry, if it's 1/2, then it's both. So this works out nicely, and we have that. So this, maybe I should have had the axis going the other way, but it starts at 1, and so you can imagine like this. We're like at 1, we're looking at the whole plot. At 90%, we're looking at this much of the plot, and so on. And so we have that it's like diffusion, 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 broadcast, diffusion. And so I don't really know what to make of this, but it's interesting because this is pretty sensitive to how we set up the frame. So it's good to look at as much as we can.
But it's not sensitive after 0.3 though. I mean, after 0.35. So that's actually
right. Yeah. And you'll see with some of them, it's right. Yeah. So you get like after like this point-ish. Yeah. Because you can imagine like if you're only looking at this, then your S curve just follows this perfect thing, and then so you can kind of see how this might work. And okay, so a few more of these. So we have Tide Pods, and sort of a similar trend. It doesn't do the big double bounce, but yeah, it's like this one's about even actually, and it stays pretty close to even for a lot of it, so that's nice.
What's your fit? Your fit looks crazy good.
Yeah, I don't have the R squareds
Okay.
or something, but I could easily rerun it and save those. Yeah, and some of the fits are worse. So this is the Harvey Weinstein story, and this one's really just like all broadcast, and you can imagine like so it like jumps up at the beginning and then curves over. So like as if we only have this, then it's like perfectly capturing that, but there's no point. It's actually 0 the whole time. So interesting as well. I thought Epstein would be an interesting one to cover because it's like not the panic. It's not like this is like a real thing that happened, but it was broken by like one reporter for like a newspaper in Florida. There's a story about the importance of local news here too. So there's like a case that maybe this could be a more of a diffusion thing, but it still is very robustly broadcast the whole time. So that was interesting to me. And then I also was interested in like, because there's like Drag Queen Story Hour is this non-controversial literacy program that's existed for a long time that became part of the culture war. And this one is really just like all diffusion until a certain point, and then it becomes all broadcast. So And I think that's because it's like capturing, like, the fit goes from doing this to this, and it's not a great fit either way. So
Is it the fit of all the data up to that point?
yes, so it's like if we have 80%, it's the fit like up to here.
So the model is saying like it's all diffusion, and then it sees another data point, and it's like wait. Everything I've seen before
yeah.
was actually broadcast.
Exactly, yeah.
Okay.
Yeah, so interesting as well. And then yeah, my last one that I wanted to do is this is that like massive like invasion query that I did with like all these context pieces of it. And this one ends up being also like more diffusion and then drops down. So this is like kind of emerging as a possible class of trend. Okay, so was really all as far as I got. So I want to talk about like the major caveats. I think people are going to talk about the intermittent power more today, but of course this like gathering the data took time, fitting the data took time, and then also intermittent power made it hard to collect data. The BAS model is really sensitive to the starting point, so I varied the ending point, but like the starting point also. So I'm still like trying to figure out a robust way to set this up where I'm not like I'm not introducing my own biases by setting the start point at a particular time. And then the number of unique shows is imperfect. So for instance, there's a Fox and Friends Saturday and a Fox and Friends Sunday, and those are like really the same show. And I think there are like lots of examples of unique shows being coded as different in some way. And so that means that those curves that I was showing in the data, they are continuing to go up when really they might, in reality, it would be more accurate to have them leveling off. And then, oh yeah, so don't know true population size. One of the parameters that the BAS model fits is the true population size, that n pop, and you know, there's potentially a way to figure out what this actually is and then fix it. There may be duplicates, I already said that. Okay, and then is that the last thing? Oh yeah, and so now it's time for questions. So yeah, thank you. And yeah, I'll take